So a rhombus, again, by definition, is a parallelogram with all equal sides. Okay, so just like with a rectangle, all the properties of a parallelogram are going to hold true for a rhombus. And in addition to this, you have the other part of that definition, which is all the sides are equal. Okay, so remember, this means the word for that is it's equilateral. Okay, so just like with the rectangle, there are a couple additional properties that are going to be true regarding the rhombus. Okay. The first of these is, again, has to do with the diagonals. So in a rhombus, not only are these diagonals bisectors of one another, so they do bisect each other. That's part of the property of all parallelograms. Okay, but in addition to that, they meet at a right angle. Okay, so the additional necessary condition of a rhombus is that the diagonals are perpendicular to each other. Okay, now I'm going to write they're perpendicular bisectors. The part of being bisectors is already embedded within the definition of it being a parallelogram, but the diagonals are going to be perpendicular bisectors of each other. Okay, and then the final property again has to do with the diagonals, and that is when these diagonals intersect these opposite angles, they're going to cut those angles into two equal pieces. So each of the diagonals will bisect the opposite angles. So not only do the diagonals perpendicular bisectors of each other, they're also bisectors of the opposite angles. Okay, so these two angles will be the same. These two opposite angles are being bisected, so all four of those angles created will also be the same.